Hello everybody, this is the Science Sound, and today we will take a look at a Math Olympiad problem. To be more specific, this problem is from Greek National Math Olympiad, and it was problem 1 of the 2024 paper. Let's begin. Let a, b, c be reals such that some two of them have difference greater than 1 over 2 times the square root of 2. Prove that there exists an integer x such that x squared minus 4 times a plus b plus c times x plus 12 times ab plus bc plus ca is negative. Before we move on with the solution of this problem, let's first take a look at some theory. Suppose that p of x is a trinomial that has two different real roots x1 and x2. Then the following equivalence is true. If t is any real number that is in between those two roots, then a times p of t is negative, or, in other words, a and p of t have different signs. For example, a can be positive and p of t will be forced to be negative, or the other way around. How do we explain that? Well, let's factorize p of x. P of x is equal to a times x minus x1 times x minus x2, where x1 and x2 are the two roots of p of x. Then, a times p of t is equal to a squared times t minus x1 times t minus x2. Now remember, t is in between the two roots. Therefore, a squared times t minus x1 is positive, and t minus x2 is negative. And thus, a times p of t is negative. So, how should we approach this problem? How do we motivate the solution? At first, we notice that the given expression is a trinomial with respect to x. Let's think for a moment, and let's forget about the integer part. Let's just prove that there exists a real number x such that the given expression is negative. If we prove that the discriminant of this trinomial is positive, then it will have two different solutions. And therefore, for every number that is in between those two solutions, the value of this trinomial will be negative. So, let's calculate the discriminant. D equals to minus 4 times a plus b plus c squared minus 4 times 12 times ab plus bc plus ca equal to 16 times a plus b plus c squared minus 16 times 3 times ab plus bc plus ca equal to 16 times a squared plus b squared plus c squared plus 2ab plus bc plus ca minus 3 times ab plus bc plus ca equal to 16 times a squared plus b squared plus c squared minus ab minus bc minus ca equal to 8 times a squared minus 2ab plus b squared minus 2bc plus c squared minus 2ca plus a squared equal to 8 times a minus b squared times b minus c squared times c minus a squared. Therefore, we have that the discriminant is positive, and that happens because one of the squares is positive, given that two of the numbers a, b, c have a difference greater than 1 over 2 times the square root of 2. Now, how do we prove that there always exists an integer between the roots? Let's visualize it for a moment. Let's add x1 and x2 in a line of real numbers. If x1 and x2 are very close, then it's very unlikely that there exists an integer in there. But if x1 and x2 are very far apart, then there always must be an integer in between. How far apart is that? If we prove that the distance of x1 and x2 is greater than 1, then we are done, because in an interval of length greater than 1, there is always an integer. So, distance of x1 and x2 is equal to absolute value of 4 times a plus b plus c plus the square root of t over 2 minus 4 times a plus b plus c minus the square root of t over 2, which is equal, after some simplifications, to absolute value of 2 times the square root of t over 2, which is just square root of t. Additionally, let's note that the discriminant is greater than or equal to 1, and that happens because one of the squares is greater than or equal to 1 over 2 times the square root of 2 squared. Supposing that, for example, a minus b squared is equal to 1 over 2 times the square root of 2 squared, and the other two squares are zeros, then the square root is greater than or equal to h times 1 over 2 times the square root of 2 squared, which is equal to 1 times 1 over 8, which is just 1. Therefore, the distance of x1 and x2 is greater than or equal to 1. Now, how do we prove that the equality is not possible? We will do that by contradiction. Let's suppose, without loss of generality, that a minus b squared is equal to 1 over 2 times square root of 2 squared, and b minus c squared and c minus a squared are both equal to 0. Then, from the last two equations, we get that a equals b equals c, which gives us that 0 must be equal to 1 over 2 times square root of 2 squared, which of course is impossible. Therefore, the inequality is strict, and there exists an integer such that the given expression is negative. And this is how the problem ends. Thank you for watching this video. If you enjoyed, please leave a like or subscribe to support the channel. It would be really helpful. See you another time.